This comes out of section 2.6, the chain rule. We've seen that if we have a composite function, something like this, y equals 5x to the 4 minus 5x cubed plus 7 to the 6, that we can take the derivative of that without ever expanding it, thankfully, because expanding that thing would be a bit of a nightmare. And we can say, okay, well, some big thing to the power of 6 is going to be 6 times that to the 5th. Don't change what's inside these brackets here, and then multiply by the derivative of what's inside the brackets, which would be 20x to the third minus 15x squared. Not too much you can do with that. We could do a little factoring with that second bracket, so I suppose to say I could take out 5x squared, so I'll have 30x squared. I've got still this 5x to the 4 minus 5x cubed plus 7, and since I took out a 5x squared here, I now have 4x minus 3. But again, the chain rule turns that question into something a little bit easier. Another way of writing the chain rule, which is a little different than I did in the last example, is, and you'll see this in the book, and that's why I bring it up, is to say, if y equals f of u, but u is considered to be a function itself, so u is g of x. Basically what we have is f of g of x, but it's written in a different way. They say that the derivative of y with respect to x is going to be dy by du times du by dx. Kind of an interesting notation. It almost looks like you can just cancel out the du's. It's not really what happens. But if I look at this one above and say, okay, well, let's call the u function the inner function. So u equals 5x to the 4 minus 5x cubed plus 7, and y is just u to the power of 6. So what does that mean? How does that work? Dy by dx is going to equal dy by du times du by dx. So dy by du is just 6u to the 5. It's the derivative of this simple one. Du by dx is up above here. The derivative is 20x cubed minus 15x squared. Now we wouldn't probably leave it that way because u is a function of x, so we could change this to 6 times 5x to the 4 minus 5x cubed plus 7, and then multiply by this 20x cubed minus 15x squared term. And if we did the factoring, whatever, we should see this is exactly what we had up above. Just the notation in between was a little bit different. So if I do another last example just with that notation, if I give you the question this way and I say, okay, y equals u to the 9 plus u to the 6 plus 2, and I say, but u equals 1 minus 3x squared. You basically have a choice now of using the first chain rule that I showed you in the previous example, or this one that's just up above on this page. Because of the way this one is written, I would suggest using the one that's on this page. You could put 1 minus 3x squared in for all the u's and then differentiate it. But basically, dy by dx is going to equal dy by du times du by dx. So we've got 9u to the 8th plus 6u to the 5th times the derivative of the bottom thing, which is negative 6x. Now, if we were asked to put this in terms of x or whatever, we'd have to go a step further to say, okay, well, that's 9 times 1 minus 3x squared to the 8th plus 6, 1 minus 3x squared to the 5th, and then all of that times negative 6x. At least everything now is in terms of x's. Sorry, I had to cram it in there. But if now x was equal to 1 or something, we could find the slope of the tangent line to this composite function. So the chain rule, lots of power.